Good morning. My topic is physical and mechanical properties of Philippine bamboos. These are two among the most important properties of timber and non-timber forest products, since this determine the suitability of wood and, as I mentioned, non-timber like bamboo for various end uses. It evaluates also the quality of our timber and non-timber, so specifically, which is the subject of presentation this morning. So when we say physical properties, this refers to moisture content, relative density, and shrinkage. So by moisture content, we mean this is just the technical term for water in wood. So bamboo, just like timber, just like our wooden species, consists of considerable amount of moisture. And this should be removed, dry to a certain level of what we call this moisture content to improve the quality of the products. This is very important because most of the problem in wood utilization stem from moisture content. If the moisture content of our wood is very high and that is not in equilibrium with the surrounding atmosphere where this particular wood will be installed, problems like splitting, checking, cracking, warping would occur. And so it is very important that we determine our moisture content. For bamboo, for instance, if we convert this to floor tiles, these our bamboo slats should be dried to a certain level of moisture required for this purpose, so that this glue or adhesive would adhere to the surface. If the moisture content of our bamboo slats is high, then most likely it will immediately be attacked by biodeteriorating agencies. So we come now to relative density. This is the amount of substance. So this is the opposite of moisture content. Now this is the substance. So the higher the relative density, the higher the strength properties. So this is an indicator of strength properties. By shrinkage, we mean this is the change in the dimension of bamboo or wooden products from initial state to a certain level of MC. And this is very important because it has something to do with the dimensional stability of our wooden products or bamboo products. How do we go about this testing or determining the moisture content? So right there in the field, with the staff from the Department of Environment and Natural Resources, we identified the plantation species and get the data, all the morphological properties, which include culm wall thickness, culm diameter, number of internodes, and the age of bamboo, which is also very important. So as well as the length, everything that needs to be recorded. So these bamboos are transported at FPRDI for laboratory testing, segregating the age. It is this one you could see divided into different diameters, segregated to different into the respective age. So this is manually prepared by cutting the nodes, and the length is specifically 1.4 meter, about 1 point meter, because this one is for bamboo floor tiles. Then cut this one from this bamboo poles, or cut bamboo into little or smaller sizes required for the purpose as is specified in the standards. This is a stripping bamboo. For moisture content, it's about 25 mm actual width. The 25 mm is the length, and also the circular one, the same length. These are samples for physical and mechanical properties as well. So for physical properties, we need to have a weighing balance, since moisture content is expressed as the ratio of density of the material to the oven dry density. So it's green weight minus oven dry weight divided by the oven dry weight. So moisture at initial weight of the samples will be taken, and this relative density by volume displacement method, you get the weight of the samples. This is oven drying, set at 103 plus -2 degrees Celsius. And then substituting this and the formula required for this particular properties. So really it's laborious and time consuming. But in the in 20,000 or lately, the Department of Science and Technology, our institute, Forest Product Research and Development Institute, through the cooperation of ASTI, Advanced Science and Technology, and Alex and Company, designed or developed a moisture meter for wood. So this is now commercialized in the market at the market price of only 5,500, as compared to imported ones, which cost about more than 50% or 100% or even more. And aside from that, is calibrated to our local wood species, unlike the imported ones where we still have to calibrate for our own species. Lately, since bamboo is already a would-be substitute for our timber, we also develop a moisture meter to determine the moisture content for bamboo, which include, among others, kawayan tinik, giant bamboo, butong, bakbak. No, it's three. Kawayan tinik, giant bamboo, and butong. This is used for bamboo floor tiles. Actually, the wood moisture meter for timber, for wood, can also be used for bamboo. But we need to have a correction factor. And so the reading, when you pierce this needle into the wood, will not automatically give the reading. So we designed a moisture meter specifically for kawayan tinik. And with this one, it's just like the moisture meter for timber, where if you pierce that into your bamboo strips, then the moisture content of this bamboo will automatically appear in the display window of this meter. Here it is the front one. This is for non-timber, the green one. This is not commercialized yet, but they can be made available by order. At least we have 10 so that we can change the program and provide this to those who would be interested in this meter. So here are the result of the physical properties of Philippine bamboos based on the studies conducted at the Forest Product Research and Development Institute. These are commercial bamboo, the erect bamboo species in the Philippines. So for moisture content, kawayan tinik, giant bamboo, widely used for floor tiles. We have moisture content of 107.2 at the back, 90.7 at the middle, 80.4 at the top. So the highest moisture content in here was exhibited by buho, about 206 at the back, 175 at the middle, and about 140 at the top portion. Kawayan tinik has the lowest moisture content, followed by giant bamboo, kawayan kiling, giant bamboo, and bayog and bolo. So all this moisture content and relative density under laboratory condition were tested and evaluated based on ISO standards 22157-2. So again, this was shown previously, the moisture content and relative density determination. And so for shrinkage, we just use the dial gauge and measure the tangential and the radial surface as well as longitudinal. Three predetermined points, each of a radial and tangential section. So again, like moisture content and relative density, this is laborious. And so this will be dried to a certain level of MC, from green to 12% moisture content to 5%, and at oven dry condition to determine the change in dimension from the initial MC to the drying at a certain level of moisture content. So in here is the result of physical properties of bilibine bamboos for relative density and shrinkage. So in this table, you could see that kawayan tinik and kawayan kilik exhibited the highest relative density, and followed by bayog and giant bamboo at the bud portion. Of course, we consider the middle. This is about 0.694 for kawayan tinik, is still the highest, followed by kawayan kiling. So more often than not, it's really the bat and the middle that are used for our floor tiles, and this is an indicator of the strength of our bamboo species. It goes to show that kawayan tinik exhibited a good relative density as well as giant bamboo. Also, kawayan tinik, almost except for buho, all these bamboo species, our local bamboo species, are comparable to relative density of Pilostachys, a species which is used for floor tiles in China. So for radial shrinkage, on the other hand, we have here the radial shrinkage and tangential shrinkage. We have here the values. So exactly we would know how would be or how much would be the change in dimension when we try our bamboo species for green to a certain level of MC. We come now to mechanical properties. So mechanical properties, this is the strength. We refer this to strength of our bamboo materials. And among these properties of mechanical, the static bending, the basic one, which are important in any materials as far as strength properties are concerned, include static bending. And static bending, there are three to measure this bending strength. This includes modulus of rupture, stress at proportional limit, modulus of elasticity. This is very important. Another important one, compression parallel, also hardness, shear, and tensile strength. So here is how, or here is a photo of how this static bending test is being determined. This one is the whole pole. The raw material is the bamboo poles in its actual size. So this is based on the size so specified in the ISO standard. They use the universal testing machine or the UTF. And we have dial gauge in here, two dial gauges. So two stop to read, to take the reading as the force is being read in this universal testing machine. So this is really laborious also, although we have now another machine which lately could register automatically the reading of the force as well as the string. So no need to compute. But in this case, this is a 4-point bending, and so we need to have this graphing of the deflection so we could compute for modulus of elasticity. Another one, this is we also have another universal testing machine. The first one, which is the load is maximum load of 200 pounds. It is still in pounds. This was almost in the 60s already, but it's still working. And this is also a 4-point bending test. Another one, the setup. You see, it's requires a lot of preparation to do the testing, the setup of the static bending test. So this one is a compression parallel where we have a dial gauge to measure also the deflection, and just like in static bending, the corresponding stress or load being read or seen in the registered in the universal testing machine. So with the defects are being observed and noted, recorded. This one is a shear test, and this one is the tensile strength. So we have here the results of mechanical properties of Philippine bamboo. So for modulus of rupture, for the six species, kawayan tinik, giant bamboo, bolo, buho, bayog, kawayan kiling, we have here bat, middle, top for modulus of rupture and modulus of elasticity. Notice that we have extremely high modulus of rupture at the butt portion of kawayan tinik, while giant bamboo, uh, and the other species, relatively really lower than that of kawayan tinik. But at the middle portion, the difference might not be as higher as compared to that of the at the butt portion. And so you could notice the properties modulus of rupture decrease from butt to top. But basically, the top portion is expected to have higher uh, high in strength properties than that of the butt or middle portion. So these are being considered in the end product, particularly in converting this into strips. For modulus of elasticity, we have these values, and for giant bamboo, kawayan tinik, bolo, buho, bayog, and kawayan kiling. So for maximum crossing strength we have here, we can see there that it's very glaring that the top portion is higher than that of the butt and the middle. We have here the node that tests with node and with internode only. Notice in here that all the values increase from butt to top. The highest maximum crossing strength is exhibited by kawayan tinik, but the values are not really, there's no big difference in values except in buho, except for buho, which is just 3.5 in contrast with that of the other species. Although it's not relatively, the difference not relatively high at the middle and top. So here is the photo of a giant bamboo in Malay Balay, Bukidnon. You could notice in here the color, which is demonstrating the age of bamboo. But this lady is the expert in bamboo. He's from the Department of Environment and Natural Resources, so we could easily identify the age of bamboo. This one is bamboo from Ilocos Norte. All the while we thought that previously bamboo is only at in Malaybalay in higher elevation, but in Ilocos it thrives well. Also, this one is in Baguio. So the marking, the different colors, so we could distinguish the age of bamboo. So this is these are the results of our physical and mechanical properties determination of 1, 2, 3, and 4-year-old bamboo from Malaybalay, Baguio, and La Union. So from this graph, notice that we have a high moisture content in Baguio. For instance, at 1 year old, it's 160, and then going down from 1 to 4 year old, 160, 117, 108, 108, and 101. Although at 4 year old, there is almost a slight decrease from 3 to 4 year old. So the highest moisture content is exhibited by this red color, which are bamboos from Baguio. So in Malay-Balay, the moisture content is lower than those bamboo collected from Baguio and La Union at different ages. Although at 3 year old, there's almost similarity. So for relative density, we have here a graph of relative density of bamboos from Malaybalay, Baguio, and La Union. So the highest relative density is exhibited by bamboos from Malaybalay, the blue one. It increased from 1 to 3 year old, and at 4 year old, relative density decreased. Also, the red one, the this is from Baguio. Notice the increase in relative density from 3 to 4 year old. And from La Union, they don't have this 4 year old. So the trend likewise is the same, although there is a slight decrease from 2 year old to 3 year old. For calm diameter, Balay-Balay, the blue one, exhibited the highest or the biggest calm diameter as compared to those bamboos from Baguio and La Union. The blue one, notice that age one, it's about 115. Those from Baguio, 85 and 106 in La Union. So the trend is likewise similar, 2 year old and in 3 year old, although it's not as distinct as in 1 year old. We also have data on the physical as well as mechanical properties of bamboos collected from Bukidnon and Mount Makiling. And results show that bamboo from Bukidnon exhibited better or higher relative density than those from Mount Makiling. And so it is expected the moisture content was lower on bamboos collected from Bukidnon as compared to those from Mount Makiling. While for radial shrinkage, similarly, we have a good or a better dimensional movement of bamboo from Bukidnon as compared to those from Mount Makiling. For mechanical properties likewise, the static bending, which includes modulus of rupture, stress at proportional limit, and modulus of elasticity, these properties from Bukidnon, the strength properties from Bukidnon were higher than those from Mount Makiling. So with the shear in the internode and node, notice the big difference in values from these two locality. So this is the range, or these are the ranges of values that were gathered from the bamboos collected from Balay and Bukidnon. And this goes to show just reflecting the minimum, the average values which I presented in in the previous slides. So the higher mechanical properties as well as better physical properties of the comes from Bukidnon than those from Mount Makiling can be attributed to the rainfall and cooler places. The higher strength property classification of comes from Balay-Balay indicates that harvesting and processing of poles from Balay-Balay for various construction purposes requiring load-bearing properties would be preferable over those from Mount Makiling, although the low modulus of rupture and modulus of elasticity may warrant consideration. The diameter and counting from La Union were generally smaller and thinner than those from Bukidnon and Baguio. However, some physical and mechanical properties of La Union poles were at par with those poles from Bukidnon and better to those from Baguio. Results show that giant bamboo also grows well in Bacnotan, La Union even with low elevation, annual rainfall of 103.3 mm only, warmer temperature of 25 to 27 degrees Celsius, and clay soil. We also had a property evaluation of engineered bamboo. Now it is the actual bamboo floor tiles using Hawaiian Tinik and giant bamboo, which are highly recommended for floor tiles based on the physical and mechanical properties as well as including physiological characteristics that were used for recommending this species for engineered bamboo. So we have moisture content, relative density, bending strength, hardness, shear, delamination, the actual one. So we took all the bamboo floor tiles produced by different companies in the Philippines, and then we also prepared a board for our testing using the uh, FPRDI procedure. So bending and hardness were tested following the American Society for Testing Materials. This is for vinyl board. Here is the testing of the static bending test of a board. Just like the raw materials, although this one is different sizes, and of course it's not the pressed bamboo, but this one is also were taken from the bamboo board prepared. Here is the minimum range of values that would serve as technical phases for development of standards for e-bamboo. So the results of tests at FPRDI were adopted by the Bureau of Product Standards, and this now serves as the range of values for e-bamboo to pass the bamboo for floor tiles. It should have this corresponding values for modulus of rupture, the giant bamboo and kawayan tinik that were gathered or evaluated based on FPRDI sample, a 121.57 megapascal, in contrast 93.01, and all data from various sources, 93 to 98. So to pass, it has an average of 95.36. We have modulus of elasticity. The passing is 13.53. For hardness, it's 609. For shear, it's 12.25 megapascal. So we also consider the minimum bamboo failure. which is about 25%, and average bamboo failure from those of various sources, it's 50. And delamination, of course, all pass the delamination test, which means that the glue used in um, this development, this producing board from pour tiles, pass the lamination test. For moisture content, the moisture should be 10.30, 10.47, and the data from various sources, it's ranges from 10.26 to 10.47, an average of 10.43. So the diameter and calm hole thickness of folds from La Union were generally smaller and thinner than those from Bukidnon and Baguio. However, some physical and mechanical properties of La Union poles were at par with those poles from Bukidnon, and better to those from Baguio. Results show that giant bamboo also grows well in Bacnot and La Union, as I mentioned, even with low elevation. Highest peak in Bagulin, above sea level, 366. Annual rainfall of 183.3. Warmer temperature of 25 to 27 degree, and clay soil. Here is the a photo of floor tiles prepared in our laboratory, and balusters. With that, thank you for listening.